Social network analysis is the process of investigating social structures through the use of network and graph theories. It characterizes networked structures in terms of nodes and the ties or edges that connect them. Examples of social structures commonly visualized through social network analysis include social media networks, friendship and acquaintance networks, kinship, disease transmission, and sexual relationships. These networks are often visualized through sociograms in which nodes are represented as points and ties are represented as lines. Social network analysis has emerged as a key technique in modern sociology. It has also gained a significant following in anthropology, biology, communication studies, economics, geography, history, information science, organizational studies, political science, social psychology, development studies, and sociolinguistics, and is now commonly available as a consumer tool. History. Social network analysis has its theoretical roots in the work of early sociologists such as Georg Simmel and Emil Durkheim, who wrote about the importance of studying patterns of relationships that connect social actors. Social scientists have used the concept of social networks since early in the 20th century to connote complex sets of relationships between members of social systems at all scales, from interpersonal to international. In the 1930s, Jacob Marino and Helen Jennings introduced basic analytical methods. In 1954, John Arundel Barnes started using the term systematically to denote patterns of ties, encompassing concepts traditionally used by the public and those used by social scientists, bounded groups and social categories. Scholars such as Ronald Burt, Kathleen Carley, Mark Granovetter, David Krackhart, Edward Lauman, Anatole Rapoport, Barry Wellman, Douglas R. White, and Harrison White expanded the use of systematic social network analysis. Even in the study of literature, network analysis has been applied by Anheuer, Gerhards and Romo, Wouter de Nooy, and Birgit Senekal. Indeed, social network analysis has found applications in various academic disciplines, as well as practical applications such as countering money laundering and terrorism. Metrics. Connections. Homophily. The extent to which actors form ties with similar versus dissimilar others. Similarity can be defined by gender, race, age, occupation, educational achievement, status, values or any other salient characteristic. Homophily is also referred to as assortativity. Multiplexity. The number of content forms contained in a tie. For example, two people who are friends and also work together would have a multiplexity of 2. Multiplexity has been associated with relationship strength, mutuality, reciprocity, the extent to which two actors reciprocate each other's friendship or other interaction. Network closure. A measure of the completeness of relational triads. An individual's assumption of network closure is called transitivity. Transitivity is an outcome of the individual or situational trait of need for cognitive closure. Propinquity. The tendency for actors to have more ties with geographically close others. Distribution's bridge. An individual whose weak ties fill a structural hole, providing the only link between two individuals or clusters. It also includes the shortest route when a longer one is unfeasible due to a high risk of message distortion or delivery failure. Centrality. Centrality refers to a group of metrics that aim to quantify the importance or influence of a particular node within a network. Examples of common methods of measuring centrality include betweenness centrality, closeness centrality, eigenvector centrality, alpha centrality and degree centrality. Density. The proportion of direct ties in a network relative to the total number possible. Distance. The minimum number of ties required to connect two particular actors. As popularized by Stanley Milgram's Small World experiment and the idea of 6 degrees of separation. Structural holes. The absence of ties between two parts of a network. Finding and exploiting a structural hole can give an entrepreneur a competitive advantage. This concept was developed by sociologist Ronald Burt, and is sometimes referred to as an alternate conception of social capital. Tie strength, defined by the linear combination of time, emotional intensity, intimacy and reciprocity. Strong ties are associated with homophily, propinquity and transitivity, while weak ties are associated with bridges. Segmentation groups are identified as cliques if every individual is directly tied to every other individual. Social circles if there is less stringency of direct contact, which is imprecise, or as structurally cohesive blocks if precision is wanted. Clustering coefficient, a measure of the likelihood that two associates of a node are associates. A higher clustering coefficient indicates a greater cliquishness. Cohesion, the degree to which actors are connected directly to each other by cohesive bonds. Structural cohesion refers to the minimum number of members who, if removed from a group, would disconnect the group. Modeling and visualization of networks. Visual representation of social networks is important to understand the network data and convey the result of the analysis. Numerous methods of visualization for data produced by social network analysis have been presented. Many of the analytic software have modules for network visualization. Exploration of the data is done through displaying nodes and ties in various layouts, and attributing colors, size and other advanced properties to nodes. Visual representations of networks may be a powerful method for conveying complex information, but care should be taken in interpreting node and graph properties from visual displays alone, as they may misrepresent structural properties better captured through quantitative analyses. Collaboration graphs can be used to illustrate good and bad relationships between humans. A positive edge between two nodes denotes a positive relationship, and a negative edge between two nodes denotes a negative relationship. Signed social network graphs can be used to predict the future evolution of the graph. In signed social networks, there is the concept of balanced and unbalanced cycles. A balanced cycle is defined as a cycle where the product of all the signs are positive. Balanced graphs represent a group of people who are unlikely to change their opinions of the other people in the group. Unbalanced graphs represent a group of people who are very likely to change their opinions of the people in the group. For example, a group of 3 people where A and B have a positive relationship, B and C have a positive relationship, but C and A have a negative relationship is an unbalanced cycle. This group is very likely to morph into a balanced cycle, such as one where B only has a good relationship with A, and both A and B have a negative relationship with C. By using the concept of balanced and unbalanced cycles, the evolution of signed social network graphs can be predicted, especially when using social network analysis as a tool for facilitating change. Different approaches of participatory network mapping have proven useful. Here participants, interviewers provide network data by actually mapping out the network during the data collection session. An example of a pen and paper network mapping approach, which also includes the collection of some actor attributes, is the *NetMap toolbox. One benefit of this approach is that it allows researchers to collect qualitative data and ask clarifying questions while the network data is collected. Social networking potential. Social networking potential is a numeric coefficient derived through algorithms to represent both the size of an individual social network and their ability to influence that network. A close synonym is the alpha user, a person with a high SNP. SNP coefficients have 2 primary functions: the classification of individuals based on their social networking potential, and the weighting of respondents in quantitative marketing research studies. By calculating the SNP of respondents and by targeting high SNP respondents, the strength and relevance of quantitative marketing research used to drive viral marketing strategies is enhanced. Variables used to calculate an individual's SNP include but are not limited to participation in social networking activities, group memberships, leadership roles, recognition, publication, editing, contributing to non-electronic media, publication, editing, contributing to electronic media, and frequency of past distribution of information within their network. The acronym SNP, and some of the first algorithms developed to quantify an individual's social networking potential were described in the white paper, Advertising Research is Changing. See Viral Marketing. The first book to discuss the commercial use of alpha users among mobile telecoms audiences was 3G Marketing by Ahonen, Casper and Melko in 2004. The first book to discuss alpha users more generally in the context of social marketing intelligence was Communities Dominate Brands by Ahonen and Moore in 2005. In 2012, Nicola Greco presents at TEDx the social networking potential as a parallelism to the potential energy that users generate and companies should use, stating that SNP is the new asset that every company should aim to have. Practical applications. Social network analysis is used extensively in a wide range of applications and disciplines. Some common network analysis applications include data aggregation and mining, network propagation modeling, network modeling and sampling, use of attribute and behavior analysis, community-maintained resource support, location-based interaction analysis, social sharing and filtering, recommender systems development, and link prediction and entity resolution. In the private sector, businesses use social network analysis to support activities such as customer interaction and analysis, information system development analysis, marketing, and business intelligence needs. Some public sector uses include development of leader engagement strategies, analysis of individual and group engagement and media use, and community-based problem-solving. Social network analysis is also used in intelligence, counterintelligence, and law enforcement activities. This technique allows the analysts to map a clandestine or covert organization, such as an espionage ring, an organized crime family, or a street gang. The National Security Agency uses its clandestine mass electronic surveillance programs to generate the data needed to perform this type of analysis on terrorist cells and other networks deemed relevant to national security. The NSA looks up to 3 nodes deep during this network analysis. After the initial mapping of the social network is complete, analysis is performed to determine the structure of the network and determine, for example, the leaders within the network. This allows military or law enforcement assets to launch capture or kill decapitation attacks on the high-value targets in leadership positions to disrupt the functioning of the network. The NSA has been performing social network analysis on call detail records, also known as metadata, since shortly after the September 11 attacks. Large textual corpora can be turned into networks and then analyzed with the method of social network analysis. In these networks, the nodes are social actors, and the links are actions. The extraction of these networks can be automated by using parsers. The resulting networks, which can contain thousands of nodes, are then analyzed by using tools from network theory to identify the key actors, the key communities or parties, and general properties such as robustness or structural stability of the overall network, or centrality of certain nodes. This automates the approach introduced by quantitative narrative analysis, whereby subject-verb-object triplets are identified with pairs of actors linked by an action, or pairs formed by actor-object.